So today we're going to talk about section 2.4, the derivative of a quotient, and derivative of a product. My bad, here we are, 2.4, the product and quotient rules. And so there's two rules we're going to talk about. The first one we're going to talk about is just the product rule. And before we go through that, I want to explain what this is saying. So this picture you have right here says you're going to take the derivative. That just means prime it, if you will. And you have to have two functions identified as separate things. Okay? Yorbic does this, and it says you take the derivative of the second function times the first, and then you add to that the derivative of the first function times the second. Now, I choose to do it in a different manner, and that's fine, because the way I do it works for me. And so we're going to go through both rules today, and we're going to talk about the derivative of a product rule, and then we're going to talk about the derivative of a quotient. Okay? All right. So the first one that we're going to do is we're going to say dy dx, and remember, dy dx is another way of saying y prime, is another way of saying f prime of x. And in this case, we have two functions. And I'm going to show you two ways to do this derivative, only because I want you to know that it doesn't matter which method you choose. If you do it correctly, you will get the right answer. So I'm going to identify the first one as f, and then I'm going to identify the second one as the g. Okay? So over here on the side, I'm going to write f of x is equal to 4x squared minus 1. That's the original function. And f prime of x is equal to 8x. Now on this side, I'm going to write the original function as identified from the original problem. And then I'm going to write g prime of x is equal to 21x squared plus 1. And I did those quickly. This is probably now the fourth day you've been doing derivatives, and so I use the power rule and the constant rule. And now I have these. Okay, so what I'm going to do now is I'm going to use the rule, which says you take the derivative of the second and you multiply it by the first. I wrote that wrong. And I'm going to go ahead and just change this color, if you don't mind. First, I'm going to group it. I'm going to change the color. I just want it to be different colors so you can see. So what I really have right here in front of me is I have g prime times f. And to that, I'm going to add f prime times g. Now, it'd be nice if I were done, but I'm not. I have to FOIL, first, outers, innards, and last, and I have to do that both times. So I'll do this one first because it's super easy. 56x to the fourth plus 8x squared. Now on this one, you might want to check your math, or check my math, I should say. I'm going to get 84x to the fourth minus 21x squared plus 4x squared minus 1. And I want to put these in order. So I want to combine all my like terms. So 84 and 56 is going to give me 140. Please check my math. Please check my math with a calculator. And then I have x squareds. So 12 good and 21 negative. So that's going to give me a negative 9x squared minus 1. And that's what I get for the answer. And again, there's a formula. You just take the derivative of the first times the second, and then the derivative of the second times the first, and then you add those two quantities. Now I'm going to show you later. I just do it in a different order. I always do f prime g and g prime f. And with product, we just add them. Okay? Remember, with addition, order does not matter. Now, that's going to be what we use for our product rule. So again, derivative of one times the other, add it to the derivative of the other times 1. Okay? Let's do another. Find ds dt if s is 1 plus t times the quantity square root of t. So remember, ds dt is really saying s prime of t. Okay, that's what we're looking for. And now s of t is equal to 1 plus t quantity square root of t. So now I need to break this up. I'll call this my f, and then I'll have its f prime. So 1 plus t, and then the derivative of that is going to be 1. And then I have my g, and that's t to the 1/2, which, remember, square root of t. And remember, we did that one in the 2.3 summary lesson. We had this example, and this becomes 1 over 2 square root of t. Now, a couple of shortcuts as we hit sections 4, 5, and 6, and the reason is this is repetitive. So we're doing the same derivatives over and over, but now we're just combining them to show how they apply with the new rule. So I'm going to go ahead and combine these. So g prime times f plus f prime times g. And we combine like terms. So we get 1 plus t over 2 square root of t plus the square root of t. Oops, not 6, t. We are not going to make you find a common denominator and do that. There's just no need for it. So we're going to go ahead and leave it like that. And remember, this is s prime. Okay, that's s prime. That's what we're looking for. All right, now we're going to take the derivative of a quotient. The derivative of a quotient. I'm going to go ahead and pause here for a second. All right, so the derivative of a quotient is really saying, how do we take the derivative of a fraction? So let me move these out of the way. Make this a little bigger. Okay, so again, we have to identify the numerator and the denominator. And this looks very ugly. And so here's the shorthand. We write it here. And I prefer the notation f prime g minus g prime f all over g squared. And so you will hear me say repeatedly, top, bottom, bottom, top, bottom squared. And so I just do it in that manner all the time. And so please just be aware that I'm just taking the derivative of the top times the bottom, derivative of the bottom times the top. Okay? And so I'll just say that to myself. It helps me remember. Okay. So we're going to go ahead and try this now. And notice that's unchanged. We're just going to square the quantity. Okay. Here we go. All right. We want to find y prime in terms of x, given that y is equal to said function. So I'm going to move this down here because I'm very short. And I'm going to go ahead and say that's f. And so f prime, this is my f. F prime is 3x squared plus 4x and minus 0. Now when I take a look at the bottom is g. And now g prime is actually equal to 1. The derivative of x is 1, and the derivative of 5 is 0. So 1 plus 0 is 1. And I will write this, and in my class I will write it consistently. F prime g minus g prime f all over g squared. So now what this does, two things, twofold. One, by seeing this, I'm reinforcing the formula in my brain so I don't accidentally screw up order. The second thing it does is everything is now labeled here in front of me. So all I'm doing is a direct substitution. So f prime times g minus g prime times f all over the bottom squared. Okay, And so if I can now, I want to simplify or do something, and I cannot. And so what I want to go ahead and do is distribute and combine like terms just to make it look nicer. And it may not look nicer, but we'll give it a shot. So I get 3x squared cubed. I get 3x cubed minus plus 15x squared plus 8. Good Lord, it's Sunday and I can't do math. I apologize. Plus 20x minus, I'm just going to distribute this to the three terms. So x cubed minus 2x squared plus 1 all over x plus 5 quantity squared. And so now we want to combine like terms. And I'm just checking my math real fast. 3x cubed plus 15x squared plus 4x squared plus 20x. Okay. And so I have an x cubed and an x cubed, and so 2x cubes left. And then I have 15, 19 minus 2 is 17. And then I have 20 x's and a plus 1. And that is my derivative. Now it looks super ugly, and that's okay. It doesn't have to be pretty. More times than not, the examples do work out a little bit nicer. But remember, we're going to be doing something with them. This is not the end point. This is just the end point for practice. We're going to end up evaluating this, finding out where it's equal to 0, horizontal tangents, and things like that. We want to use this to evaluate a function. So we're just going to go ahead and leave it like this. In my class, no, I do not make you FOIL out the bottom. Okay? We do FOIL at the top to see if it simplifies, but the bottom can stay. Okay, this is where some of us need to really focus, and please, please, please pause and ask questions if you're doing this at home and it does not make sense. So the first thing I want to do is pull this down so I can touch it. And this is F and this is G. So F prime is 2x and G prime is 4x cubed. Okay? So now I've done the baby work, and so now I want to look at what I'm asked to do. It says graph y equals f of x, and use your graph to make some rough estimates of the locations of all horizontal tangent lines. Okay, so we're going to put a couple of sections together here. First off, graphing this, I would be thrilled if you could do that without your calculators. However, this is homework, this is practice, and you can see here, there's a picture of what that graph is going to look like, okay? So you're all right if you just use your calculator. You should have something that looks like this. Note here, the windows. So you're going from negative 2.5 to 2.5 and then negative 1 to 1. And the x's are counting by ones. And the y's are counting by ones as well. Okay, so here's what we're going to do. We're actually going to do part A. We're going to make rough estimates of where all horizontal tangent lines might be. Okay, so I'm just going to come up here. Excuse me. I'm going to go ahead and grab a horizontal line. And I'm going to go ahead and I'm going to clone that for right now because I'm thinking I might have two places, so or more. So there's one, I think. And let's go ahead and make another one and see if this is tangent to the curve at anywhere else. Maybe right there. I'm going to go ahead and shrink this line. So I think I have a matching one on the other side. I think there's going to be another one kind of right there. And so those would be my estimates of where I think my horizontal tangents are. So I'm just going to shrink these lines up a little, just a little, so you can see a little bit better. Okay, so there they are. Those are my horizontal tangents, or where I think they are. But now it says, and here's the part where it gets hard. By differentiating, that means to take a derivative. So to differentiate is to derivatize, to take the derivative of. Find the exact locations. Okay, so in my head, I know I'm looking for this. And so the derivative of that function. Now, keep in mind, I've labeled an f and a g only so that it looks like the rule. So remember, f prime g minus g prime f all over g squared. Important note here, I'm choosing f and g. I could have very well chosen p and q, s and t, u and v. It doesn't matter. But when we say f and g, these are arbitrary letters. I can pick any letters I want. What I'm really signifying is top, bottom, bottom, top, bottom. Okay? Notice the G is on the bottom. So as long as my convention stays the same, my answer will be right. Okay? Letter doesn't matter. So direct substitution now. These are the four pieces I'm going to use to plug in. So f prime G minus G prime F all over the bottom square. Now, I can simplify this a little on top. 2x to the fifth plus 2x minus 4x to the fifth plus 4x cubed all over x to the fourth plus 1 quantity squared. Now the important piece here is up here. I'm going to scroll up for a second. Let's go back to section 2.3 for just a few seconds. Horizontal tangent lines. What is that telling me about the derivative of a horizontal tangent line? When I take the derivative of a horizontal tangent line, what is the value that I get? Okay, remember 2.3. Derivative of a horizontal line, we're thinking slope of a horizontal line. What is the slope of a horizontal line? Yell it, yell it. I don't hear you. Okay, it's 0. I'm going to have to believe you. Okay, so 0 is the slope of a horizontal tangent. Okay, it's now asking me to tell the book, tell the teacher, tell somebody, where is this very ugly thing equal to 0? And I would say, where is that ugly thing equal to 0? And the only way a fraction or any number could be 0 is if this is 0. So now what we really want to do is we want to revisit algebra 2. So I'm going to make the top look a little prettier, but this is the equation that I need to solve to answer the question. The denominator is irrelevant. Does not matter for horizontal tangent lines. Okay? Does not matter. The bottom is what we use for vertical tangents, undefined, things like that. When we're talking about horizontal, we're thinking top. So on top, I have negative 2x to the fifth plus 4x cubed plus 2x equals 0. Now, I'm going to go ahead and go to algebra 2, and I'm going to pull out the greatest common factor, a negative x. And I'm going to get 2x to the fourth minus 4x squared minus 2. And I'm hoping that factors, but oh, guess what? Another factor. They have a 2. So there's an x to the fourth minus 2x squared minus 1. And if I'm not mistaken, that's really that. So now what I want to do, algebra 1. Algebra 1 says 0 product property. Set each piece equal to 0. Set each piece equal to 0. Ms. Collins, why do you have this written twice? That's why, sweetheart. That's why. Okay, so now where are the only places that we can make this thing equal to 0? Well, at x equals 0, I'll remind you. And you're going to get it at 1 and negative 1 and 1 and negative 1 and 0. So the 3 places I think it could be is 0, 1, and negative 1. Those are my 3 guesses. Now, just to be clear, I kind of guessed that in the picture, but just to be clear, I want to come back up to the original function and make sure that I don't have any domain restrictions. X to the fourth plus 1, no matter what I plug in there for x, it's always going to be positive and it will always be greater than 0 or not equal to 0. So remember, I'm looking at that in my head. X to the fourth plus 1 has to be not equal to 0. And there's no place that's going to happen. So that makes me happy. Yay! So now I can come back down here and say, yes, these are the 3 places where there's going to be a horizontal tangent. I don't have to exclude any. They're all included in my original functions domain. So the 3 places I will have a horizontal tangent will be x equals 0, x equals 1, and x equals -1. Okay, so just to summarize, you have some rules for differentiation. This is for, in simple terms, finding derivatives. Okay, finding derivatives. I like to use the word derivatize. Okay, we're going to derivatize in my class. Okay, so if we're going to add functions, you can split them up. That also works for subtraction. Okay, if you have it like this, you can rewrite it. Okay. A constant times a function is just the constant times a derivative. Here, constant function is 0. This is going to be your product property. This is going to be your quotient rule. Okay. This is a shortened version of the quotient rule. I would prefer to use power rule over that, but either way, you're going to get the right answer. And then this is power rule by itself, okay? Keep in mind, that is the same as that. We used to say nth power. The book uses r. It's the same exact thing. All right, here's your quick check on page 167. Now, for the quick check exercises 2.4, the answers again are on page 169 in your book. The quick check is on page 167. If you can't read these, you can go to page 167 and answer them. These very much so are quick check exercises this time, okay? Be prepared to do a lot of these in class tomorrow, all right? Good luck.